while we are working on our little tech
Are
issues always. Good times.
All right. Well, welcome everyone to
I think we are.
Learning for All with Lego Education. My name is Kelly Reddin, and I'm joined by Dr. Leanna Prater.
Hi, I'm not on camera. That's because we're going to be using a document camera for a little bit to do some hands-on stuff. But I did put my little happy, playful friend here under the camera, which I think is representative of me most days, smiling and really ready to engage and play with friends of all ages.
So first, the thing that we'd like to know is how familiar
right,
are
Kelly,
you with Lego education? If you would put this into the chat, we'd appreciate it. If you are unfamiliar, you really haven't ever heard of Lego education before, or you might have heard the words, but you have no idea what we do, if you would put blue in. If you know a little bit about Lego education, then would you please put yellow into the chat? And if you use our products or you really are pretty familiar, would you put magenta into the chat? So I see some blues, some yellow. I have a Magneta. How about magenta?
Blue, some yellows. Nice mixture.
Yeah, blue and yellow. All right. So it's a mixed group of people who do or do not know much about us, and that's great. Oh, somebody's used both Spike Prime kits and EV3. Excellent.
Awesome.
All right. So we want to start today with a question for you, and I'm going to put this into the chat. So I'm going to give you this this answer garden in the chat, and that, whoops, I'm going to go back. It's sneaked up on me there. So I'm going to put this into the chat, and we are going to ask you to think about what is the function of literacy. So it's coming in to your chat. You should be able to grab that link and go to the answer garden. So what do you think the function of literacy is?
And just to let you know, if you haven't used Answer Garden before, you just type your response where it says type your answer and hit submit. And as people share ideas, they will populate the word cloud below.
We started with
communication. See what others are sharing.
We'll see if we get a few more answers in there that are different. Knowledge acquisition, gather, share, communicate information, the practical skill set needed to read, reading for knowledge, comprehension, growth, so we have several ideas about the function of literacy, and I'm going to continue on. And
okay. Hold on a second, Kelly. Go back one slide because I want to ask some questions here for a minute. Thinking about this idea of function of literacy, because I think that we have a lot of great ideas that have been shared. Obviously, the idea of communication is really important because we know that literacy typically when we talk to educators or even just the general public, and we ask, really, what does it mean to be literate? People often tend to go back to those ideas about the ability to read and the ability to write, or the ability, even if you think of like mathematical literacy, right? The ability to use numbers, all of which it kind of comes back to that idea about communication. And we know that people needed to have those skills today and in the past, really, to be functional citizens in society, if you would think about it in that way. And I would argue too that sometimes when we think about literacies for today's world, I think that encompasses a lot of other literacies as well. What are some other literacies that you think about when you think about things that people need for today, maybe to be literate citizens? And you can just add your ideas in the chat. So outside of reading and writing and maybe mathematics, what other things would you say would be important literacies for people to have? Yeah, Vicki, digital literacy. It's really very important. Thinking about the technology side of things. Anyone else? Yeah, as it relates to the real world. Great, Kyle. Great thought there. Give us a minute to think. I know when I was in the classroom and even working at the district level, thinking about digital literacies, about how to use technology is so important. Even things like information literacy, knowing how to acquire information, and even things like invention literacy. There's this whole idea around the need for people to be able to think of tools and things in different ways to be able to create things that they need for today's society. But thinking about going back to thinking about the ability to read and write and do math for a minute, for me personally, it made me think about where that idea came from, right? And so we know a long, long time ago, like back in the Middle Ages or even before that, when we had a spoken language and we had a written language, that language that was written might have been on signs or buildings, and even though people spoke the language and communicated verbally, they really didn't know how to use that language to express their ideas in a written form or communicate with each other in writing or even read ideas or information from others. So it really limited what they could do. And so being literate back in the day really meant that you had power, or you were wealthy, or you had some kind of status, or something along those lines. But even today, it means that you have more job opportunities because you can read and write. You can advance your own knowledge in other areas. You might have the opportunity to become more educated because you have those skills, and then those opportunities continue to increase because of that. So I think when we think about literacies today, I think it's interesting to think about this idea around what does functional literacy really mean, and what are those skills that people really need to have? Okay, Kelly, I went off on my little tangent there, so you can move on to the next class. And so I love this quote from Marina Bears. So Marina Bears is from Tufts University. Just a little bit of information about her. If you're in the computer science space at all, or even in technology, instructional technology, educational technology, I always suggest Seymour Papert as somebody who's really an interesting guy to read and read his work. And he was really ahead of his time back in the 80s. But Marina Bears was a student of Seymour Papert's, and she actually I think ran in the same circles at MIT with like Mitch Resnick, who's the creator of Scratch, which we're going to hear a little bit about from him in a minute, and a lot of other things. And pretty much a lot of tools that we see that are used out in the classrooms today that really allow for that introduction of computer science in the classroom with like block-based programming and stuff almost always go back and point to Seymour Papert and the work that he did. But I really like this quote from her because she talks about those things that we were just talking about, this idea of, you know, literacy as being a way of thinking and communicating and expressing your ideas. And, you know, when we think about it through that lens of reading and writing, you know, those who can't read or write are kind of left out of some power structures. And so that really becomes an equity issue for us as a society because we are not providing everybody the same opportunities to interact with each other, to express themselves, or even, you know, move ahead in the job market. And in thinking about that for just a minute, when we think about computer science, a lot of times we hear this phrase like CS for all. And I like to ask this question because it was a question that was asked actually at a Scratch conference several years ago. And I think about it all the time. So, you know, you have a good question when you think about it all the time. And they simply asked, who is the all in CS for all? And when you think of the all for CS for all, who do you think of as the all? So just add in the chat there. Who are the all that we are thinking about? I always say CS for all, and then add your word at the end there. Yeah, ages and backgrounds, absolutely. Anyone else thinking of anything? Sure, all ages, all backgrounds, all abilities, all levels of students, those who are just starting, those who maybe need some more advanced ideas. I love the idea of all ages because we think of young, old people as old as me. That we, oh yeah, that, you know, that because really if we're thinking about it as a literacy, it really is something that everyone needs to know and understand. And when we think about where we're typically teaching these classes, I don't know about you, but when I started down this path a little bit, really the only place in my district we offered it was an after school. So take a minute to think about like, where is computer science typically offered where you are? Is it within the classroom? Is it an elective course? Is it only after school? Or is it something that you will have worked maybe as a school or district to really begin to embed within the classes, you know, often for students across grade levels, regardless of what class they're taking? Maybe think about that for a minute. Because for me, when I was started to really think about just offering, you know, we had a robotics club after school, and that's really where we were offering this opportunity for kids, I really started to think about who were the kids that were getting left out. You know, the kids who couldn't stay after school for whatever reason, or we were making them choose among different after school activities. You know, and then when we got into even hour of code events and things like that, you know, it was a one-time thing. And if you missed school that day, then, you know, you might have missed it for the whole year. So we were leaving a lot of kids out unintentionally. And I think it was because we just never really stopped to really think about it and consider it. And so when we think about it, really as skills that you need to have today to be literate, it's important that we begin to think about providing those opportunities for all kids. And so we're going to show a really quick little clip from Mitch Resnick, and I'll put the link to the entire video in the chat if you want to watch the entire thing. But he has a really interesting kind of view around this idea of computer science as literacy and the benefits of learning how to code for kids beyond job opportunities. So Kelly's going to cue the video up there for us.
So if you think about writing, why do you want to learn to write? Of course, some people will grow up to become professional writers, become a journalist or a novelist. Most people are not going to make a living as a writer. But still, think it's important for people to learn to write. But why is that? Well, it's partly because writing can be useful in our everyday lives. Everything from a simple writing a letter to a friend, writing down a shopping list. There are many practical reasons we might want to write. But also, learning to write helps us organize our ideas. It helps us express our ideas, to sort of take our ideas out to the world. And I think the same is true for coding. Coding is not just about learning to make a living and preparing for a job. Programming can also be very useful in our everyday lives. The same way that you might write a letter to a friend, you can use coding to make an interactive birthday card for a friend. Also, learning can be helpful in organizing your ideas and helping you learn to think more systematically and to express your ideas.
Thanks, Kelly. So he has this really interesting idea about, how when we learn to write, we write to learn. And when we learn to read, we can read to learn. And it's the same idea around coding and programming. When we can learn how to program and code, we can use that skill to really help us understand other things. So I'm going to put the little link down here in case you all are interested in going back. Oh, that's Answer Garden link. That's not going to help you at all. To read his entire, or to hear his entire little talk there on YouTube. Oh, thank you, Kelly, for sticking that in there. Great. If you want to advance to the next slide for us. So when we think about computer science really as this idea of as a literacy, sometimes that term is kind of complex, right? So when you hear computer science, what are those things that you actually think about when you think about computer science? Just add in the chat there some ideas. Yeah, programming and typing and coding. Yeah, robotics. Data literacy. Branching out a little bit. Great. Yeah, so Kelly, if you go on to the next slide there. Georgia actually defines computer science as the study of computers and algorithmic processes. So that's a lot about, programming and understanding the processes behind that. Principles of computer science. So there's a whole group of things clustered around that. Both hardware and software. Sometimes people forget, or they kind of think about one and maybe not the other, or the fact that we work in computer science to kind of marry those two things together, and then rolling it out, or that implementation process of that. But just as important, this idea around the impact on society. Just because you can create something, should you? Are the risks greater than the reward in that regard? And when you also think about this definition, they also talk about how they blend with these concepts of computer science. So that it's very an integrated approach. and that they should be taught in that way, that these concepts and practices should be taught in an integrated way in order to be a very authentic learning experience for all students. Yeah, Kristen, thank you. Ethics and computer science. It's really important for us to think about those things. And I like to think about this very broad definition of computer science because sometimes people think if I'm an English teacher, computer science isn't really something that I address. But it is absolutely something that you could talk about in a lot of different ways. Same thing for like a social studies teacher when you think about impacts on society and thinking about how technology over time has impacted society, which is just kind of an interesting thing to think about outside of allowing students to create with code to actually show understanding in any discipline that you're working within. So with that being said, one of the broad concepts actually around computer science is something called computational thinking. And computational thinking is the process, if you're not familiar with it, it's a problem-solving process that they use within computer science. And it's something that's really easy to bring into your classroom. When we think about this integrated approach, and we think about allowing for equitable opportunities for our students to really begin to understand computer science, some unplugged activities are something really easy to do. So Kelly's going to walk us through a little activity with computational thinking. And if you have some paper or pencil, you can join along.
So what we do is make a grid that's 4 by 4 on a piece of paper. If you have Lego bricks, choose 4 of each of 4 different colors. But if not, it's okay. You can either just write on the grids with those 4 colors, or you can tear up something with different colors on them. So you'll see that we have 4 by 4 grids because we've made this dark line down the center and across the center. So we will have 4 columns, 1, 2, 3, 4, and we'll have 4 rows. Now, we've chosen these 4 colors. It does not mean that you have to, but we're going to use yellow, magenta, blue, and black for our 4 colors. And then we'd like you to set this up. So you have whatever your color 4 is in these 2 spots, whatever your color 1 is in these 2 locations. So this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And then we have 4 positions within each. So if you'll set that up on yours while we're waiting. Okay. And what we want to do is we want to solve for what are in these blanks right now. That's what we want to do, is we want to solve that. And we would do that through decomposition, breaking it down into small parts, looking for patterns. Then we're going to solve the problem 1 step at a time, which is the algorithm portion. We're going to evaluate and figure out if we can improve it, our methods, and debug it, and then make an abstraction. So the first thing I'm going to do is decompose the problem. And I might say, well, what steps am I going to use to figure out the brick color for each space? So if I'm looking at what would go in this very first square, which is in the first column and the first row. First column and first row. Well, I could look down at what's missing in row 1. So I have black and yellow in row 1, but I do not have magenta and I do not have blue in row 1. Then I look at the bricks that are missing from column 1. And I do not have in column 1 black or blue. And I look at what's missing in quadrant 1, and I do not have magenta or blue. So if there's only one brick or one color that was missing from all three sets, then that must be what goes in the upper left cell. So we had blue and black in the column. We had blue and magenta in the row, and we had magenta and blue in the quadrant. So blue was the only one that was in all three. So we did not have two colors that were in all three lists. We only had one. So we must know that blue goes in this location right here. Okay. So I'm going to look at row 2, this block now sorry. And I want to say, if it is in column 3 and row 2, what's missing? I'm going to do the same thing I did before. Row 2, what's missing? Magenta and black. In column 3, what's missing? Black and blue. And in quadrant 2, what's missing? Magenta and black. So there was only one brick missing from all three sets again, and that was black. So we are going to know what this block is. Now, let's go to the next slide and talk about patterning, because when we were going through that, we noticed a pattern between the first and the second set of directions. So the first thing we looked at was what's in the missing row on both row 1 for the column 1, row 1 in quadrant 1. And then we looked at in the second set where we were looking for the bricks that were missing in row 2, column 3, second quadrant. So we looked at the bricks missing in row 1. So now our abstraction becomes look at the bricks that are missing in row blank, row X. That's our variable. And then we're going to look at the bricks that are missing in column X. So we've seen a pattern here where we can create our variables. Once we've done that, we can answer all those questions. We can fill in just like Leanna has, and we can then verify to make sure that every column and every row and every quadrant has 4 different colors. Now, the next step would be to give another grid with different colors in it or different positions and say, try the directions we just created, and does it make this work? Can we solve the problem with those written directions of row 1 or row X, column X, quadrant X? And it will work in that fashion. We can tell you that. And then after you've done that with the students, then the next step is to have the students create their own puzzles, So that is a little harder than it sounds, because you can't just like say, all right, I have this complete, and then push everything. So I take what's in row 1 and put it into, what's in row 4 and put it in 1, 1 goes to 2, 2 goes 3, 3 goes 4. Doesn't work that way because we've changed quadrants as well. So we've taken things from quadrant 4 and put them into quadrant 3 and quadrant 1 into quadrant 2. And so it doesn't really work that way. Kids can sometimes, they'll create a pattern, but they will have to think about it. So most of the time, what you might do is have the kids create one with all the blocks on there, and then take blocks off and see and they can take more blocks off and see if you can still solve it using the method that we've given them, and they can trade theirs. So I think that in professional development, you know, when we're on site, we include videos of teachers teaching. And this is a way that you can get your students, you know, you can see how other teachers work with students on this, as well as having students, you know, create their own puzzles and work with one another and go through that. So we will be providing a link to some resources at the end of our presentation so that you can go in and visit those professional development sites. They are of no costs to you. You have to register, but you'll be able to go in and you can see a lot of different ideas and activities. Leanna.
Yeah, thanks, Kelly. Thanks for sharing. And I love this computational thinking activity. I would love to say that, you know, Kelly and I came up with this all by ourselves, which is so not true. It's actually a modified activity from a fabulous book that I don't have laying around here, which I'm sure I do have it laying around here. It's just not where I can grab it quickly. But it's a book by Kiki Protzman and Jan, I can't remember her last name, Kelly. We'll make sure we put a link to it or
Yes.
mention it. But it's a great book about computer science and teaching computer science in your classroom. And if you're a teacher who's just getting started in that space, I found it extremely helpful to understanding concepts and things like that. So it is one of my favorite books out there. So, so the next little unplugged activity we're going to do is called the memory game. And Kelly, I'm just going to ask you to quit sharing the slide deck just so my my document camera will be really big here. Thank you. So the memory game is really a fun activity. It's something you can do. Kelly and I get asked all the time, like, what are some things you can do with just Lego bricks if somebody has donated them to me in the, in the classroom, or if I've purchased things from Lego Education and I have these sets in my classroom, is there other things I can do with them beyond the lessons, right? And so you have this great resource of materials and tools. And so we're hoping to share some just other ways that you can leverage those resources in your classroom. So when we think about the memory game, it's really a little activity around sequence. And when I talk about sequence, where else in, like what other disciplines is sequence important, or do we talk about sequence? I don't know if I have any elementary teachers out there. You can add in the chat. Other places we taught where sequence is taught. Yeah, it's in also, that's right, Vicki, it's like everywhere. As I was sitting here thinking about, sequence and language arts, I had a fond memory of my math teacher, Lucas. Interesting that you mentioned that. And order of operations, because sequence is really important in doing your order of operations, isn't it? So this activity is designed around that. I'm using Duplo blocks just because it makes it a little easier for you to see, but by all means, you can use whatever Lego bricks you have available to you. And we're just going to start with color. And so when we talk about sequence in this memory game, we're going to start at the bottom, which is a little different because most people, when they count, they'll start at the top and go 1, 2, 3. But when you build with Lego bricks, and if I were to write directions for how to build, the bottom brick is your first brick of your build. So we're going to start at the bottom and go up. And so the way this works is you show a set of bricks to your students. I'm starting with 3. This is what I would do with kindergartners. And you show them the bricks in order for about 30 seconds. And then you hide the bricks. And then the students have to either build the same sequence if they have their own bricks that they can use, or draw a picture, maybe with crayons or markers, and highlight the colors in order, or somehow record that even with words if they don't have bricks. And then you show it to them again to see if they're right. So it's kind of, let's see how well you remember. Oh, Gina, that's awesome. I love that. Love that you'll have to put in the chat whether or not your kids really enjoy that. But I'm going to test your knowledge here real quick. So I'm going to show you a sequence of 3 for 30 seconds, and then just put in the chat to see if you remember what the order is. So remember, 1's down here. All right, now put in the chat, let's see who remembers. I have some people who are really paying attention this morning, and you have excellent memory. I need to work on this skill myself because I lose my car when I go to park in the parking lot at the grocery store because I can't remember where I park sometimes. So memory games are probably good for me too. So then I can actually, make it a little more difficult. 3 was not too hard. Let's see how we do with 5, right? So with kids, you can start with 3, then go to 4, then go to 5, and increase the complexity. So we'll give you about 30 seconds here. All right, now let's see how much you remember. You can put in the chat there. A little harder. Oh, great. Y'all are with it. You can test your memory. And then you can actually kind of vary this experience up a little bit. So you can begin to do things like this. And now I have 6 bricks. But what do you notice that I've included now that I didn't have before? Anybody notice something that kind of jumps out? Yeah, it's a pattern, right? So we have a pattern that we've introduced in here. So this memory game is a great way to also introduce patterns and help students recognize patterns. And I have a pretty simple pattern that I have going on here, but it's kind of fun sometimes to make more complex patterns because sometimes they're hard to see, but they're really important when we think about programming and computer science. Now, with all that being said, just to let you know, we're using color today, but that is not the only thing that you can use. So I just have some random Lego bricks. I have a lot of random Lego bricks in my house. I'm sure Kelly's the same way. But you can do this instead of with color, with shape. So I have bricks that are different shapes, squares, rectangles, and circles here, and I could stack them and have them recall based on the shape and not necessarily the color, or I could have them recall with both. So then I'm getting a little more complex in this activity that would definitely push its way on up into upper elementary, middle school, and maybe even high school if you wanted to get really complex with some memory games and patterns and things like that. Okay, Kelly, I'm going to have you share again really quick just to talk about the computer science concepts behind this little activity. And as she's pulling up the slide, just real quick, it is under the umbrella of algorithms and programming for sequencing and patterns. And there's some ideas on how you could do this with young students as well as older students. So, I use the Duplo bricks for the little people. I taught kindergarten, so that one-to-one correspondence was something we worked on a whole lot. And for the older kids, I would still start out a little simple until they kind of get the hang of it. But you can really increase the complexity, making those patterns even more complex. And then those computer science concepts and practices are listed underneath as to what they address. And if you think about sequencing and patterns when you think about programming languages, if you go to the next slide, Kelly, these are just some of the computer science solutions that we have with Lego Education. And I wanted you to kind of see how this unplugged activity really leads into some other things. And so like with Coding Express up at the top, that's a solution we have that's all physical computing. So the sequence part comes in play with the track, with storytelling, beginning, middle, and end. Looking for patterns, they have actual little tags that you can lay, action bricks that you can lay on top of the track, so you can create some patterns with your train as to how it's reacting on the track and what it's doing. And then when you move into our icon-based language with We Do 2.0, that's a nice sequence structure there too. And then over in Spike, you might notice our Spike language is based on Scratch. Some of you might be familiar with Scratch programming language, but we begin to pull in that repeat block, right? So as I'm programming in Scratch, I might notice there's a series of blocks, and even with We Do, there's a series of blocks I'm using over and over and over again, so that pattern, I recognize that. And instead of, putting all those bricks in over and over and over again, I can cluster them and use a repeat block, or even a my block if I wanted to create something and pull it back in. All right, so real quick, we're gonna do one other activity called Guess My Brick, which I really like. Sometimes when we think of computer science, we think a whole lot about that algorithms and programming side of things, but cybersecurity is kind of an interesting area to think about too, data and privacy and things like that. So if you unshare real quick, Kelly, so they can see, we're going to talk about this little activity that's fun to do even with little kids. So I'm going to have a treasure. My treasure is going to be my little duck here. And I'm going to put him in a box so he's safe. And I want to unlock my treasure so I can retrieve it. And I'm going to use a password, but my password is only going to be 1 brick long. It's going to be one of these 3 colors. My password is either going to be green, blue, or yellow. Okay? So I've picked a password. See if you can guess what my password is. Remember, it's only one of 3 colors, green, blue, or yellow. Let's see how easy it is to guess my password. Oh, Sonia's guessing yellow. If I were to say nobody's cracked the code yet, that might be a telling tale. Yeah, Vicky's like, oh, yeah, some of you are all great listeners, right? So my password was green, right? Really easy to guess. In fact, how many tries would it take somebody to guess that password before my duck is loose and on the run? It would take 3 tries, yeah. In 3 tries, they would have guessed my password. Not very secure. So this activity, you can then move up to the next little level, right? So maybe I'm adding another color. So now I have 4 colors, but instead of being 1 color long, now it's 2. And so you have to guess both colors and you have to guess them in order, right? So that would be the next level of complexity. So we'll do this real quick, see if you can guess. Red, yellow, blue, and green. See if you can guess my password. That's 2 colors long now, and you have to guess them in the correct order. Color 1 and color 2. Let's see if you got them. Okay, some good guesses. Nobody's cracked my code yet. Our little duck friend is safe. Yeah. Nobody's guessed yet, so for the sake of time, I'll show you. It was yellow and blue, but it's a little more complex, right? Not super hard. Eventually, you could figure out what it is with enough tries probably. So this is a fun activity to do with kids, right? Have them start with 2 brick colors, or 3 brick colors, I mean, and work with a partner, see how many times it takes them to guess the password. Then move to 4 colors and maybe try. Then move to, 2 colors in order. Then 3 colors in order. Then maybe 4 colors in order. And then maybe you can move from colors and pull in like color and shape, right? Or color and shape, and with Lego bricks, you can even talk about function. If you wanted to connect something, or if it's a Technic if it's a brick or a beam, or this is actually called a biscuit. So you can kind of make it more complex, because I think if you were like me when I used to teach passwords to kids, they would complain that their passwords would have to be really long and contain an uppercase and lowercase letter and a character and all those fun things. But it really allows them to see why we do that, and why it helps us keep our information secure and protect ourselves and protect our devices and things. And Kelly, I'm going to have you share real quick again. I know we're getting close to time. But there's a great lesson. I think the next slide just really talks about cybersecurity, how you can do this activity with younger kids, how you can do it with older kids. You can even have the older kids calculate out possible combinations. I was trying to think of combination and permutations at the same time. That was a lot for my head to process, which is a great way to use math for that. And if you go to the next slide, we actually have a fun lesson in Spike Prime that's around keeping it safe. So then it's taking this lesson around cybersecurity and password protection and moving it over into this idea of how can I program things that allow me to keep something safe through programming, which is a nice little spin there. All right, so move on to the next slide there. Hopefully you saw like the activities that we shared, and thinking about the CS for all, and thinking about equity, and thinking about making sure that we're pulling it into classrooms and things like that, that they have a low floor. It's kind of easy to get started. They work a lot well for young kids. It has a high ceiling. You can make it more complex. It fits into lots of different disciplines, which is nice as well. And Kelly, we'll just get you over. So I want you to this is a thinking question. I want you to just think about, how do activities like the ones we shared today really help bridge those equity gaps that we're trying to address when we think about computer science, and this idea that everyone needs these skills in order to be literate for today's world. And then if you go to the next slide there, Kelly, what are some things that you can do as an educator right now in ways that you can bring these into the classroom? And I'm going to hand it back over to Kelly so she can share some great resources we have for you too that are out there.
Thanks. So set up here, and we can put in, you can grab these, but for Lego education, we have professional development. We have some where we come to your school and do face-to-face when that's available, and we've had to switch to virtual as everyone else. But we also have a beautiful new resource that is a self-guided online. It has no cost, and it has a great set of lessons that will help you as a teacher become a better facilitator, get more of the 4 C's in your classroom, that creativity, communication, collaboration, and critical thinking. It has pedagogy points. It has materials management in there. There are a lot of different ways, these things on STEAM. So really encourage you to go in and look at that. They are, in many cases, something that you can apply beyond Lego education. And we also have a community site where you can meet and talk with educators around the world. And then we also have our lesson plans. They're all no charge, so you can go on and look at any of our lessons that we've created. And we've even created some lessons that are on the Scratch website. So Scratch link, and we have our own education activities. So then we also, we also have added in here the research by Marina Bears and Mitch Resnick's talk on coding. And we do have middle school and high school with no cost for the coursework that we've written, computer science courses. They use Spike Prime as the tool. But you can get those from Sonia Glasper. We also would be glad to answer any questions that you have. Sonia will be your direct contact in Georgia, and she's on screen with us now.
Hello, everyone. It's a pleasure to meet you via this tool, and so excited to be able to service you here in Georgia. So please do not hesitate to contact me. Look forward to working with you.
All right. And if you have any questions, you can come off mute and put them or put them in the chat. So Leanna has put into the chat some of these links. So she's put in the overview for professional development, and she's put in the community site, and she's put in the lesson site. So you are welcome to look at any and all of those. And again, if you are interested in looking at the computer science coursework that we've created for middle and high school, please don't hesitate to reach out to Sonia, and she can just send you the PDFs so that you can have them and go from there. Leanna, do you have any closing? Okay. Are the links that Leanna shared the same as the links that were shared on one of the previous slides? Yes.
Yes.
Yeah, I'm trying to grab the link to the Scratch projects because they are free. They're kind of fun. They have Lego bricks, images and stuff in the project. So they're up there to be remixed. And there's some lesson plans that go with them that you can find actually in the Lego education community. So all of that's up there. There's one of the grasshopper journey around a studio for creating a journey with Lego education. And then I actually probably should put the link back to our just Lego education page, which you can kind of see, which is great. Thank you all so much for taking your time today and joining us for just a great discussion and thinking about computer science as an important literacy for this day and age, and just some ways to kind of begin to bring those ideas into your classroom to address equity issues that we know that may inadvertently exist, and ways that we can help address those problems.
Thank you for joining us. Have a great day.
Thank you so much. Have a great day, everyone.
I guess we'll hang on for just a minute if somebody has a question that they need to ask before we completely jump off.
Awesome. Thank you for joining us, Lucas.
I always feel like we should have music playing. The silence.
I know it. Did you see in the chat, Leanna, Adam wanted to know how to get your slides?
Oh, that's a great question, Adam. Sonia, what's the easiest way to get the slides to them?
If I had his email address, if you don't mind putting your email address, Adam, then we can make sure that you get those.
Yeah. And Sonia's email is on that slide right there, soniaglasper@lego.com. If you email her too, we can make sure that you get a copy of that.
Awesome. I see it, Adam. I'm going to make sure we get that to you. Take a pic of it.
Oh, thanks, Adam. I'm looking forward to when we can be on the road and be out to play in person, you know?
Yes, me too, Leanna.
But for right now, it's great to even play in virtual spaces.
That's right. Here we go. Leanna?
Yeah.
Yes, I think that we are probably in good shape now
Okay.
in terms of the presentation. Well, any other questions from any others that we may be able to assist? Okay.
I think we're good.
We're good.
Well, thank you all so much again for joining.
Thank you. Have a great day, everyone.